Hello, I'm going to talk for about 10 minutes, and I've been asked to speak to the question, what is the life expectancy of the Great Barrier Reef? It's actually a question I'm asked quite often. Will we have a Great Barrier Reef? Will the world have coral reefs in 50 or 100 years' time? So in Australia in the last 2 years, as I'm sure many of you are aware, we've seen two back-to-back coral bleaching events. We've actually had 4 events now in the last 20 or so years. The first was in 1998. That was a real wake-up call for Australian coral reef scientists because it was the first time we'd ever seen a bleaching event. It happened again 4 years later. Then we were lucky enough, in hindsight, not to have any bleaching for 14 years. And now, tragically, we've seen the first back-to-back bleaching in 2 consecutive years, this year and last year. 2 of those years, 1998 and 2016, were El Nino years, but the other 2 were not. And increasingly what we're seeing around the world is bleaching events now occurring throughout ENSO cycles, even in La Nina periods when temperatures are slightly cooler. And the reason for that is that in the tropics, La Nina years now are warmer than El Nino years were 30 years ago. So the cause of these bleaching events is not El Niños per se, it's global warming and increases in temperature. So I'd like to show you a short video of what bleaching looks like from the air. So in March 2016 and again this year, I spent 7 days flying the length and breadth of the Great Barrier Reef, documenting the footprint, the geography of these 2 massive bleaching events. So what you're looking at here is footage from a helicopter in the northern third of the Great Barrier Reef, where the bleaching last year was very extreme. So bleaching is a stress response by corals. They turn white because they lose the color that they get from the microscopic algae called zooxanthellae that live inside their tissues. So a bleached coral is nutritionally compromised, and if the bleaching lasts longer than a few weeks, we start to see mortality of corals, which in 2016 and 2017 was quite extreme. So we also measured the extent of bleaching underwater, and this graph here shows the relationship between the level of heat exposure on the x-axis using a metric called degree heating weeks, and the y-axis is the percent bleaching we observed while diving underwater, and each of those dots is a different reef. And you can see a very strong relationship between the amount of heat stress, the amount of heat exposure, and the level of bleaching that occurs underwater. And we've published our preliminary results on the extent of bleaching in 2016 in the March 16th issue of Nature. Tragically, 2 days before that paper came out, I got back on an airplane and a helicopter to resurvey the second bleaching event. So this is our preliminary data for the 2 footprints of the bleaching in 2016 and again this year in March, April. So the red dots are bad. That's where the most severe bleaching occurred. More than 60% of the corals were affected on reefs that are red. And the green dots, that's good news. That's reefs where less than 10% of the corals were bleached. So in 2016, we saw bleaching that was very much a northern affair. North of Cairns, all the way up into the Torres Straits, up to New Guinea, was very severely bleached, but the south escaped. And in 2017, we have a different geography, relatively mild bleaching in the north, but severe this time in the central region, and again the southern region escaped. Those 2 footprints can be explained very precisely by where the water was hottest in each of those 2 years, and the same is true for the events in 1998 and 2002. But between those 2 events, this year and last, fully 2/3 of the Great Barrier Reef has now been severely bleached in just a 12-month period. So a key question is how many of these bleached corals survive and how many die? And we haven't yet published that information because the bleaching is actually catching up with our ability to collect the data and to publish it. So here is a preliminary graph of the mortality, which we published in the Conversation. with my colleagues from the Great Barrier Reef Marine Park Authority and AIMS, the Australian Institute of Marine Science. So it's a map showing the extent of mortality in 2016, and it's color-coded. So the green area in the south had no bleaching and very little mortality as a consequence. The opposite extreme occurred in the north. So the red region, which is about 700 kilometers long, experienced a median mortality rate, loss of corals, of 67%. When bleaching occurs, it's actually very selective. Some species are much more susceptible than others. So the more susceptible species in the north, in that red region, have suffered mortality rates in excess of 80%. The mix of species has changed. It has probably changed forever because the likelihood of getting a fourth, fifth, and sixth bleaching event in the 10-year period that it takes for these corals to recover is now extremely high. And of course, we have now seen a back-to-back bleaching. Across the entire Great Barrier Reef in 2016, 30% of the corals died. That includes the southern region where no corals died. And this year, our preliminary estimate of mortality, mainly in the central region, is 19% mortality across the entire Great Barrier Reef. Those reef-wide figures, I think, tend to underestimate the losses. Basically, we've lost close to 2/3 of the corals in the north last year and close to 50% of the corals in the middle section of the reef this year. And the sobering thing about these losses is that they have occurred with approximately 1 degree of average global warming since the pre-industrial period, and global warming, of course, is continuing apace. So Australia has a plan called the 2050 Reef Sustainability Plan, which is the major framework for managing the Great Barrier Reef into the future, hence the name 2050. The objective of the plan is to improve the World Heritage Values, the Outstanding Universal Values, or OUV, of the Great Barrier Reef World Heritage Area, decade on decade into the future. However, the OUV of the Great Barrier Reef have just been severely damaged because all elements of the World Heritage Values of the World Heritage property depend on healthy assemblages of corals. So I would argue that the objectives of the 2050 plan are no longer achievable and they need to be reformulated. Specifically, I believe the goal of the 2050 plan should be to be more forward-looking, to preserve the Great Barrier Reef in a changed condition so that it remains functional into the future. So the plan needs to be more forward-looking, because maintaining the values of the reef that were there when it was inscribed as a World Heritage Property in 1981 is no longer achievable. The plan needs to address climate change as well as water quality, which is the current major focus of the Great Barrier Reef. So returning to the question, what is the life expectancy of the Great Barrier Reef? This is a question that my colleagues and I are asked repeatedly for many years now. And coincidentally, we have just written a paper about it. So in the next couple of weeks, we'll publish this review paper called Coral Reefs in the Anthropocene in the journal Nature, which will address this question. So I'll just finish up by giving you a very brief summary of what this paper says. Firstly, we argue that reefs face a climate gauntlet, that they will transform but not disappear under the COP21 climate targets. So those targets, as you know, are for achieving a global average temperature of somewhere between 1.5 degrees centigrade and 2 degrees centigrade. Now, there's quite a lot of confusion about what those degree centigrade numbers mean for the tropics. The level of heating captured in the COP21 targets is the global average. So it includes tropical waters, tropical land, and of course the poles. It's the whole planet. And an important point is that if the world does warm by 2 degrees, tropical oceans will warm by a significantly lesser amount. So far, tropical oceans have warmed by about 0.75 degrees centigrade on average. And under the COP21 2-degree target, they will warm by another half a degree centigrade. Clearly, the 1 degree of warming which has already occurred is not a comfortable place for coral reefs. We're seeing more and more bleaching. But I do believe if we achieve the COP21 targets that we will be able to maintain functional reefs, but they will be very different in terms of the mix of species of the reefs that we see today. So I believe our goal should be maintaining functional reefs, which will require a radical change in how we do coral reef science, management and governance. And a big challenge is looking after reefs, not just in terms of global warming, but also the other major threats that they have to endure, particularly pollution, which is the major focus currently of the Reef 2050 plan, and also overfishing. So I'll drop that slide and just conclude. So I would argue that the 2050 plan needs a radical overhaul to acknowledge the impact of global warming. Coral reefs do have a future, but it's a very different future. The mix of species that was observed on the northern Great Barrier Reef before April last year is probably not, again, attainable in our lifetimes. Climate change remains the elephant in the room in terms of management strategies around the world. Climate change and other key drivers need to be wound back to be decreased, and they need to be incorporated as additional targets in the Reef 2050 plan. And finally, we have to stop emphasizing band-aid approaches. The elephant in the room is climate change, and that's what we need to address to secure the future of the Great Barrier Reef.